Today we're talking about hyperbolas, and again we have 2 days here. The first day we're looking mainly at graphing these things from the equation, and then on the second day we are reversing the process and we'll be building the equation themselves. So let's go over some vocabulary here and some features of them. Once again, we're going to have an axis here where we have 5 critical points. We have the center. On either side of that we have the vertices, and beyond that we have the foci. Now, this is not called the major axis the way it was with the ellipses. They changed the name on us. We call it the transverse axis because we are crossing over. We are transversing the 2 branches. These are disconnected branches, as you can see, whereas the ellipse, you could almost imagine like these branches be pointing inwards and creating that shape. We are now pointing them outwards. So notice that the branches are running, it looks almost parallel with these slanted asymptotes. So part of what we're trying to do is figure out where do these diagonal asymptotes get placed, because then we can draw the branch through the vertex and running close and almost, it looks parallel to those diagonal asymptotes, all right? What that means is we need to know where's the we need to know where's the vertex placed, and that's the A that you're seeing right here. So that distance is the A. We still have the distance to the focus, that's the C. So notice now the focus is further from the center than the vertex. That means the value of C will be bigger than the value of A. And then in this direction, we don't really have anything. They still give it a name. I believe they call it a conjugate axis, but we don't really call it anything because there's really nothing here except this value of B is the distance to this top part of the box. So we're going to be creating this box, which is B units above and below the center, A units to the right and to the left of the center, and it's through those opposite vertices that we're going to be drawing those diagonal asymptotes. So we need to know the A and the B, and then of course the C to get the focus. So here are the 2 possible orientations of the axis, the transverse axis. If it is horizontal, then your branches are opening left and right, and if it is vertical, your branches are opening up and down. Notice some differences in the equation compared to the ellipse. The ellipse we were always adding, but now we're subtracting one fraction from the other. And because the order matters when you subtract, we now have to consider whether x is in front or whether y is in front. And that was different than the ellipse, where x was always in front. And so what I'm doing here is I'm saying, okay, if x is in front, then I associate that with the x-axis, which runs horizontal, and that means my transverse axis must be horizontal as well. If y is in front, I associate that with the y-axis, which of course runs vertically. Therefore, our transverse axis must be parallel to the y-axis. It is also vertical. So that's how I keep track of which axis goes in which direction. Another difference here is that the a squared is always in front and the b squared is in back. This is different than the ellipse. With the ellipse, the a squared was always on the larger denominator, but now it could be larger or smaller. It's always in front. All right, so once again, what we're doing here is we're finding the center, so C for the center, and then we have our pair of vertices, we have our pair of foci, and these were determined by the length of A and C to get to the focus. So again, there's really nothing in the other direction. That is, there's really no other item except we need the value of B to create that distance so that we can figure out the boundaries of this box, right? So that's what we're looking at. They'll go through the 2 vertices and then that distance of B. So what that means for us is we want to write the equation of this slanted line, and that means it has a slope. So we need to figure out what the slope is. Our slope is rise over run, and the way we'll do this is we'll go from the center to that top right corner. So we'll go up and over. So that means in this case we have a slope of up B units and over A units. And then for the other direction, it's just the negative version of that. This slope here is negative B over A. So what that means is we're going to be writing the equation of these lines using that ratio for our slope.